We'll be taking a look at solving logarithmic equations. To do that, we're going to take a quick look at the laws of logarithms, and then we're going to examine the steps that we follow when trying to solve logarithmic equations. So here are the basic rules of laws of logarithms that we're going to use throughout this lecture. So we have log to base a of p plus log to base a of q is going to be equal to log to base a of the product of p and q. Log to base a of p minus log to base a of q is the same as log to base a of p divided by q. Now if we have log to base a of p with an exponent n, this ends up becoming n, which is the exponent, comes to the left hand side, multiplied by log to base a of p, and then if we have log to base a of 1, we have 0, and log to base a of a, we have 1. Now let's look at how we're going to solve logarithmic equations. First of all, we want to make sure that the logarithms are of the same base, and then we're going to apply the laws of logarithms to the logarithmic equations that we have, and then next thing is to solve the equations created, and we have to test the answers to make sure that they are valid. So we're going to start off really simple. Log to the base 2 of x equal to log to the base 2 of 2. So we see here log to the base 2 here, log to the base 2. So because of the log because the log has the same base on both sides, then x must be equal to 12. For these two sides to be equal, the only thing that is unknown is x. It must be equal to 12. Now let's look at this one here. Log to base 2 of x squared is equal to log to base 2 of 5x minus 6. So we have log to base 2 here, log to base 2 here. So that means that x squared must be equal to 5x minus 6. Now we're going to create a quadratic equation here. So this is going to give us x squared minus 5x plus 6 equal to 0. Now we're going to factor this quadratic equation here. So this is going to give us x minus 2, x minus 3 equal to 0. So we have x minus 2 equal to 0, and then we also have a scenario where x minus 3 equal to 0. Here we add 2 on both sides, so x equal to 2. Here we add 3 on both sides, so x is equal to 3. Now what we're going to try to do is we're going to see if we can plug it to any of the sides. So x equal to 2. Let's put that for on the left hand side. Log to base 2 of 2 squared is 4. So we have a valid expression there. X equal to 3. Log to base 2 of 9 is valid. So x equal to 2 or 3. Let's apply the same thing here. We have the same log and the base here. So x squared minus 30 equal to 7x. Let's rearrange. We have x squared minus 7x minus 30 equal to 0. So let's factor this. We're going to have x minus 10 x plus 3 equal to 0. So x minus 10 equal to 0, x plus 3 equal to 0. We add 10 here, we add 10 here. We subtract 3 on this side, we subtract 3 on this side. So here x equal to 10 and x equal to negative 3. So let's look at this. We're going to try to plug this into Let's look at the left hand side. X equal to 10. So 10 squared is 100 minus 30, 70. Positive, so that's a good number. What about negative 3? Negative 3 squared is going to give us 9. 9 minus 30 is negative 21. We can have a negative number we can get the log of a negative number. So what we're going to do here is we're going to say x equal to 10 because it's the only valid number that makes this equation accurate. So now we have this situation here. 2 log to the base 2 of x equal to log to the base 2 of 4 plus log to the base 2 of x minus 1. So this can be rewritten as log to base 2 of x squared equal to log to base 2 of 4 multiplied by x minus 1. So now when we compare both sides, x squared equal to 4x minus 4. So now what we're going to do is rewrite this expression as a quadratic equation. So we have x squared minus 4x plus 4 equal to 0. We're going to factor this equation and solve for it. So we have x minus 2, x minus 2. So we have x minus 2 squared equal to 0. So x minus 2 equal to 0. We add 2 to both sides. So x equal to 2. So let's see how that works. We substitute 2 for any one of the variables here. So let's look at this. Let's look at the original equation. Log to the base 2 of 2 minus 1, that works. Log to the base 2 of 2, that works. So x equal to 2 is a valid result for x. Now let's look at this example. Log to base 4 of 7x plus 2 plus log to the base 4 of 9 equal to log to the base 4 of 2x. When we apply our laws of logarithm here, we have log to the base 4 of 9 multiplied by 7x plus 2 equal to log to the base 4 of 2x. So here we have log to the base 4 on both sides, so we just equate the expressions. So 9 7x plus 2 equal to 2x. So 63x plus 18 is equal to 2x. I'm going to subtract 18 from both sides, and I'm going to have 63x equal to 2x minus 18. Let's subtract 2x from both sides. And so we have 61x equal to negative 18. And so we divide both sides by 61. So x equal to negative 18 over 61. Now, because let's try to substitute negative 18 over 61 in any of these. So negative 18 over 61 here, we're going to end up with a negative number. And also in this case here, we end up with a negative number. So we can say no solution. With this one expression here, we have this equation here. Log to base 3 of x squared minus 6x is equal to 3. So here's a rule that we're going to take note of. We know that log to base a of a equal to 1, and we know that log to base a of p to the power of n equal to n log to base a of p. So what we end up with here is going to be 3 times log to base a of a. So let's substitute here. So we're going to end up with log to base 3 of x squared minus 6x is equal to log to base 3 of 3 cubed. Now, there's another way you could look at that. One other way to look at that is because if we have a to the power of x equal to b, what this ends up meaning is that log to base a of b is equal to x. So in this case, we can also rewrite it this way. 3 to the power of 3 is equal to x squared minus 6x. That's what this is going to end up being. So 27 is equal to x squared minus 6x. So we're going to rewrite this. We're going to have x squared minus 6x minus 27 equal to 0. And let's factor this. We end up having x minus 9, x plus 3. So we have x minus 9 equal to 0, x plus 3 equal to 0. So we add 9 in this case, and we have x equal to 9. We subtract 3 in this case, we have x equal to negative 3. So let's see if both of these values are valid. So let's plug in 9. So 9 squared minus 54. So that's going to give us 3. Okay. Negative 3 squared, which is 9, plus 3 times 6, which is 18. So that gives us 3 as well. So x equal to negative 3 or 9. So these are the values of x. So this is just a elementary logarithmic equations. In this case, we're not having to deal with natural logarithms or any of that sort. So this is more of an intro to solving logarithmic equations by applying the laws of logarithms.